Good day everyone guys. In today's feature, our topic will be electrolysis. So what is an electrolysis? Electrolysis, the use of electric current to stimulate a non-spontaneous reaction. Electrolysis can be used to separate a substance into its original components or elements. And it was through this process that a number of elements have been discovered and are still produced in today's industry. In electrolysis, an electric current is sent through an electrolyte and into solution in order to simulate the flow of ions necessary to run an otherwise non-spontaneous reaction. Processes involving electrolysis include electrorefining, electrosynthesis, and the chloralkali process. So we have four factors affecting electrolysis. So first one, we have overpotential. The overpotential. The generated voltage is significantly higher than expected. An overpotential may be necessary to overcome interactions taking place on the electrode itself, especially for gases. Number 2, electrode type. An anode electrode acts as a surface for a reaction to occur on and is not involved in the chemical reaction, whereas an active electrode becomes a part of the half reaction. Simultaneous electrode reactions. If two different pairs of half reactions take place at once, sub-half reactions should be eliminated in order to determine a single pair of half reactions best suited for the electrolysis to occur. And lastly, we have the state of reactants. If reactants are in non-standard states, the voltage of half cells may differ from that of the standard amount. In this case, the solution for the anode half cell may have a pH that is either higher or lower than a standard pH of 4, which may lead to a non-standard voltage as well. So we have several processes for the electrolysis that are still used in today's industry. So first is electrorefining. So electrorefining, the anode is the impure metal and any impurities are removed during the process of electrolysis. When the metal travels from anode to cathode, during the electrorefining of metals, the cathode has a decomposition of pure metals from a solution containing the metal ion. For example, copper is purified through electrolysis in order to be used for applications that require high electrical conductivity. During this process, the cathode is a pure piece of copper, while the anode is an impure piece of copper. The Cu2 plus from the anode moves through a sulfuric acid copper 2 sulfate solution into the cathode where it becomes a solid copper. While this is occurring, the impurities are left at the bottom of the tank. This leftover residue is called anode mud. The electrolysis is carried out at 0.15 to 0.30 V, which is a low voltage, in order to ensure that Ag, Au, and P2 impurities are not oxidized, while in the anode it becomes anode mud, whereas most of the other components becomes oxides or hydroxides and form water-soluble species. So number 2 is electrosynthesis. So electrosynthesis, a method which uses electrolysis reactions to produce certain products. For example, MnO2 needs to undergo electrolysis in order to be used for alkaline batteries. The solution for the electrosynthesis of MnO2 is MnSO4, in which H2SO4, the anode is graphite, where Mn2 plus is oxidized, while the cathode, hydrogen is reduced from H plus to H2. So number 3 is chloralkali process. The electrosynthesis of seawater which leads to the production of chlorine and alkali, sodium hydroxide. There are three different methods in which these two components are produced: membrane cell, diagram cell, and mercury cell processes. For the mercury cell process, electrosynthesis of seawater in a mercury cell leads to the production of chlorine and sodium hydroxide at the same time. This method involves using mercury as the cathode and graphite as the anode. The mercury attracts either sodium or potassium cations, and the mercury forms an amalgam with it. However, when the amalgam is introduced to water, it forms sodium hydroxide, and hydrogen leaving the mercury to be reused later. The chlorine gas is left to form the anode. Now we move to the diagram cell process. The diagram cell has Cl2 being released from the anode section, while there is H2 being released from the cathode section. If Cl2 managed to mix with NaOH, the Cl turns into other products. Therefore, the diagram cell has a bigger amount of NaCl and a smaller amount of solution in the cathode in order for the NaCl to come with other solution gradually, while simultaneously preventing backflow with NaOH. And lastly, the membrane cell process. This process is more efficient than others as it does not use mercury and does not require a significant amount of energy. Contains a cation exchange membrane which is usually made from fluorocarbon polymer. This membrane allows hydrate cations to pass in between the anode and cathode compartments, but does not allow the backflow of the ions, Cl negative and OH negative. This allows a sodium hydroxide produced to have less contamination by chloride ions. So that is all, guys. Thank you for watching the electrolysis.